Hello बच्चों, let's read the given question. The question says an automobile approaches a barrier at a speed of 20 meter per second along a level road. The driver locks the brakes at a distance 50 meter from the barrier. What minimum coefficient of kinetic friction is required to stop the automobile before it hits the barrier? Option A given a 0.4, option B is 0.6, option C 0.8, option D 0.5. So in this question we need to understand as a key concept. यहाँ पे हमसे पूछा जा रहा है कि कितना टाइम लगेगा और बेसिकली कोएफिशिएंट ऑफ फ्रिक्शन के बारे में दे आर आस्किंग. सो वी मस्ट अंडरस्टैंड about work energy theorem, that is W net is change in kinetic energy. W net is what over here, that is work done by all the forces whether conservative non conservative. अब conservative की बात कर रहे हैं, so gravitational force, spring force, elastic force या फिर electrostatic force are all conservative force because they are independent of the path, right? Whereas conservative force non-conservative force are dependent on path like frictional force. ठीक है ना? So यहाँ पे बात हो रही है friction force की. So we need to consider that non-conservative force here. Also we know force of friction, that is given by the formula mu into mg, or that is coming derived from mu into n, that is normal reaction. ठीक है ना? अब यहाँ पे also we need to be careful that के work done is positive and negative. So positive कब होगा? जब kinetic energy final, change in kinetic energy को हम kf minus ki लिख सकते हैं, that is final minus initial. So final, if final is greater than initial, so work done will be positive, and if initial is greater than final, so work done will be negative. ठीक है? So from this discussion we can try to answer the given question. अब हमसे पूछा जा रहा है कि automobile approaches at a speed, हमें speed given है 20 meter per second along a level road. The driver locks the brake at a distance of 50 meter from the barrier. ठीक है? What minimum coefficient of friction is required? यानी कि let's suppose there is a barrier or there is hurdle in the on the way we can say, and this automobile is coming, and here the distance is 50 meter when driver has applied the brake, right? So kitna it has been asking ke what will be the minimum coefficient of friction required to stop the vehicle so that it will not hit the barrier. ठीक है? So from this we can say initial kinetic energy से final kinetic energy zero हो जानी चाहिए so that it will stop and will not hit the barrier, right? So हम क्या लिख सकते हैं? Final will be zero over here, so इसको हम zero कर देंगे and minus of half mvi square, right? And that will be equals to, यहाँ पे अगर हम देखें तो कांस्टेंट फ्रिक्शन फोर्स लग रही होगी इन द बैकवर्ड डायरेक्शन, एंड एज डिस्कस फ्रिक्शन फोर्स हम क्या लिखेंगे? म्यू mg into 50, right? Mu mg तो force है and displacement is 50, so this will be the frictional work done by friction force. And since we can say displacement is towards right and work force is in the left direction, so though both are in the oppositely directed, so इसीलिए हमने यहाँ पे negative sign लगाया है. And that also can be understood, work done is fs cos theta, right? So cos theta will be and theta is the angle between force and displacement. So यहाँ in this our case यहाँ पे angle is 180 degree, so this comes out to be negative. अब इसको solve कर लेंगे just, and we will be getting the value of mu. So यहाँ पे mu is mu k, and that will be equals to m मास तो यहाँ से कैंसल आउट हो जाएगा दोनों तरफ से. ठीक है? सो यहाँ पे बचेगा vi स्क्वायर मीन्स 20 का स्क्वायर, दैट विल बी 400 डिवाइडेड बाय 2 इंटू जी की वैल्यू 9.8 ले लेंगे एंड इट विल बी 50 ओवर हियर. सो फ्रॉम दिस वी कैन से this can be written as 0 0 and this will get cancelled out, 4 upon 9.8, and that will be the value of mu k, and it comes out to be 0.408. So this is the answer to the question जो कि मैच होगा ऑप्शन ए के साथ. I hope you understood the solution. All the best.